Assalamualaikum, grade 6 students. In chapter number 5, atom molecules, mixture and compounds, we're going to revise today whole chapter. We have studied atoms and elements. If you take any material, cut it into smaller pieces, one time will come when it will not be further divided. It cannot be seen even by a powerful electron microscope. That tiny piece of particle is known as atom. There are different types of atoms present everywhere around us, but the material made up of only one type of atom is called element. Element is having all type of atoms which are same. Only one type of elements are found in element. Scientists have discovered a total 117 different elements. Some of them are rare, most of them are common, and few are man-made. We can't see atoms even under electron microscope. We need STM, scanning tunneling microscope, to observe atoms. Here, atoms are drawn. Okay, see, this is the figurative diagram of atom. This is also a figurative Niels Bohr model of atom. This is also a Bohr model. This is also a diagram. This is also a diagram in which this part, central part of atom is nucleus. In nucleus, there are positively charged protons and no charge, neutral particles called neutrons. Outside of atom, outside of nucleus, around nucleus are electrons moving around nucleus. Okay? Now we have studied that there are 117 elements present in this universe. So elements are made up of only one type of atoms. These atoms are given a short name that is called symbol. Water pipe, for example, are made of copper. Copper is an element because it has only copper atoms. So copper symbol is Cu, capital C, small u. Steel, on the other hand, is not an element. It's a mixture of atoms which are like iron, carbon, and chromium individually. But here we are studying elements and their symbols. So scientists use symbols as shorthand for different elements. Hydrogen symbol is H, capital H. Carbon, C. Nitrogen, N. Neon, Ne. First letter is capital, second letter is written small. It's always the rule. Boron, capital B. Helium, capital H, small e. Lithium, capital L, small I. Right? Magnesium, capital M, small g. Aluminium, capital A, small l. Copper, capital C, small u. Potassium, K. Gold, AU. Now you will be thinking that potassium name should be P, but it's actually its Latin name. That's why it's written here K. Sometimes scientists write the symbol of elements with their Latin or other words names, not English words, right? Like gold, aurum, AU, silver, argentinum, AG, right? It's not their English name, it's their Latin or Greek name, right? Iron, ferrum, Fe. Done? Now, element symbols are done. We are moving to our next slide. We have studied here metals and non-metals. The elements are further divided into metals and non-metals. Metals are shiny, especially freshly cut, are hard and strong, are dense, heavy for their size, are good conductors of heat and electricity, have high melting and boiling points, are solid at room temperature, can be drawn into one or hammered into shape, are sonorous, making a ringing sound when tapped. Few are magnetic, for example, iron, coal, and nickel, while most are non-magnetic. Bismuth is diamagnetic. It actually repel magnet. Okay, so non-metals are very less in number, and they are mostly dull because they do not reflect light very well. They're very weak or brittle, have less density, are bad conductors of heat and electricity, except graphite in your lead pencil. It's carbon actually, have low melting and boiling points, easily melt or boil at room temperature. If they are solids, then they are weak and brittle, while many are gases. Are non-snorers, don't make any sound when they are tapped, are non-magnetic. Again, the same thing is told here. Periodic table. The green are the metals and the yellow are the non-metals. Metals are having high melting points, good conductors of heat, good conductors of electricity, can be easily shaped, malleable. Non-metals have low melting points, poor conductor of heat, poor conductor of electricity, cannot be easily shaped. Okay, brittle, right? Here are the some uses of metals, like they're used in making airplanes, they're used in making bridges, and non-metals, they're used in filling balloons. Oxygen is very important. Non-metal, we can't live without it. We can't breathe without oxygen. Even we can't live 1 minute without oxygen. Okay, next is molecules and compounds. When two or more atoms are combined together, they form molecule. If the atoms are same, molecular elements such as hydrogen, oxygen gas, like oxygen gas has 2 oxygen atoms with chemical formula O2. If the atoms are of different types, they form molecular compounds, such as one molecule of water has 2 hydrogen atoms covalently bonded together with 1 oxygen atom and with chemical formula H2O. Now here some compounds are written, their formulas are written, and the name of elements are written which are present in them. Number 1 is carbon dioxide. Carbon dioxide is made of carbon and oxygen, CO2. Methane, carbon and oxygen. Methane, CH4, carbon and hydrogen. 1 carbon atom, 4 hydrogen atoms. Sulfuric acid, hydrogen, sulfur, oxygen. Hydrogen 2 atoms, sulfur 1 atom, oxygen 4 atoms. Okay. Aluminium sulfate, aluminium, sulfur, oxygen. Aluminium, sulfur, oxygen. Aluminium sulfate has 2 aluminium atoms, 3 sulfur atoms, and 12 oxygen atoms, altogether 17 atoms. Okay. Molecules and compounds. Here are some examples. This is DNA molecule that is found in all cells of living things. This is CH4. This is again CH4. This is something else. This is again molecule of a compound because its atoms are different. Now mixtures. There are substances that have more than 2 elements or compounds which are not combined chemically but are just mixed. It's called mixture. For example, seawater, oil, milk, lemonade, petrol, gas, glass, mineral water, and gemstone. Mixtures are impure, so their constituents can be separated by number 1, filtration, number 2, evaporation, sublimation, distillation, paper, chromatography. Now, this technique, filtration, is separation of insoluble solute from the mixture. Evaporation is the separation technique of soluble solute from solution. Sublimation is the separation technique of the particles that are not converting into liquid, that are directly changing from solid to gas. Mostly it is done for iodine crystals and ammonium chloride salts. Distillation is a process in which we boil the mixture. The different components having different boiling points separate differently. Paper chromatography is done for the separation of ink or paint dyes, and it is done easily in lab as well. This diagram is actually showing the different types of techniques properly. We have discussed all these diagrams in detail many times. That's enough for separation techniques. This is sieving. We have done it: filtration, evaporation, condensation, chromatography, distillation. In your book, we have done fractional distillation of oil, crude oil as well. Thanks for watching. Allah Hafiz.